Hello everyone, this is Suraj here. Welcome you all to my channel. Today we will discuss about the basic structure of a Terraform configuration file. See here, we have main.tf file and within this file you can see three main blocks are there. First is Terraform block, second one is provider block and the third one is resource block. So today we will understand what does these blocks mean. So first one is Terraform block. If you see within this Terraform block, required version is written and required provider is written, right? So what is required version? Required version means you see it is greater than equals to 1.0. That means the Terraform version. Which Terraform version will be used in main.tf file? So greater than equals to 1.0 means it will be equals to 1.0 or greater than equal 1.0. So like the values may be 1.5, 1.8, 2.0, 5.0, 6.5, anything like that. And what is that provider will be using in this configuration file? The provider is AWS, right? The thing is that I have written AWS here in line number 5. You may write XYZ, then also it will work as a AWS provider. How? The thing is that in line number 6, the source equals to HashiCorp slash AWS. This is very important. It depends on the source. It does not depend on the name which you have written. This source is the provider source from where the provider will be getting installed, right? So HashiCorp slash AWS will be internally converted into registry.terraform.io slash HashiCorp slash AWS. This is the full URL, right? And what will be the version? The version is still greater than 4.0. The version is of provider version, not Terraform version. This is the Terraform version, required version, and this version within this required provider block, this version is a provider version, right? And what does this mean? Tilde. See, tilde greater than 4.0 means version will be 4.0 or greater than 4.0, but it will not reach 5. Okay, let me explain. If it is 4.0, the possible values may be 4.1, 4.2, 4.3, but not 5.0. That means if tilde is there, then the rightmost digit will be increased or rightmost digit will be decreased as per the condition. Fine. Okay, so come to the next block. So this is provider block. You can see provider AWS. So if in the line number 5 we have written XYZ, then in line number 14 also we need to write XYZ, right? And you see we are just initializing one region, in which region our resources will be created. So we are writing US East 1, right? And here we are writing profile equals to default. So why profile is used? Profile is used to authenticate to the AWS account in which we will be creating some infrastructure, right? If we write profile equals to default, then from where Terraform will get the credentials to log into AWS. So it will take the credentials from credentials file stored in your local system. You can authenticate to AWS account using profile. Otherwise, if you are not willing to use profile, then you can directly push access key and secret key in this configuration file. Fine. And the third one is resource block. You see, using this Terraform configuration file, what we will do? We will create one S3 bucket named surojbera2023. So this is resource and this is the resource type and this is the name of the resource type. Fine, or the reference name of the resource type. See here. So what is Terraform block? The Terraform block type is used to configure some behaviors of Terraform itself, such as requiring a minimum Terraform version provider to be used and backend where Terraform state file will be stored. So I already have shown you in the code that in Terraform block we have mentioned which version of the Terraform will be used, which provider will be used in that configuration file. Means all the behaviors of Terraform will be defined inside Terraform block. And by default, Terraform uses a backend called local which stores state as a local file on disk. Fine. So once you will apply the Terraform configuration file, then one state file will be generated, and in the state file all the resources which is managed by Terraform will be defined or will be mentioned. The Terraform state file will be stored locally if you do not manually mention the backend. Provider block. The provider block type is used to define a provider which will be used in the current configuration. And here, what was the provider we have used? We have used AWS provider. And what we have defined inside provider block? We have provided the credentials and what will be the region in which our resources will be created, right? So this block also includes credentials to connect to the provider. A resource block. The resource block type is used to define a resource which will be created in the cloud. So see, so for an example, resource, then AWS SQS queue and Terraform queue, right? And name of the queue will be fast Terraform queue. So first one is resource block. So that is why you have written resource, and AWS SQS queue is the resource type, and Terraform queue is the reference name of the resource type. And what will be the name of the SQS queue? That is fast Terraform queue. Now, what we will do? We will initialize this Terraform configuration file. Let me go to terminal, new terminal, next cd terraform cd03, right? And if I write dir, see main.tf file is there. Okay, now I will write terraform init. See, terraform has been initialized successfully. Now what we will do, we will run terraform validate. Terraform validate to validate the configuration file. See here, the configuration is valid, fine. So whatever we have written in main.tf file, it is a valid configuration file. Now let's run terraform plan. Terraform plan. See, in the terraform plan, what it is saying? It is saying 1 to add, 0 to change, and 0 to destroy. So what it will create? Let me go up. See, plus means create. That means AWS S3 bucket dot terraform S3 bucket will be created, right? So what is AWS S3 bucket dot terraform S3 bucket? See here, this is AWS S3 bucket dot terraform S3 bucket. Inside this resource block, what is there? Bucket equals to Surojbera 2023. This is defined. So that means if we run terraform apply, one S3 bucket will be created with the name Surojbera 2023. One thing to observe here, you see after running terraform init, .terraform.lock.hcl file has been generated and another folder .terraform has been created. What are those? So .terraform folder is nothing but the provider. Which provider? You see here it is AWS provider. The source of the AWS provider is registry.terraform.io/hashicorp/AWS, right? So the provider has been downloaded and it is stored in .terraform folder. So if I expand this, see terraform/provider/registry.terraform.io/hashicorp/aws/4.50.0/windows_amd64, right? And if you see, this is our provider, this is the file, right? And what is .terraform.lock.hcl? This is a terraform log file. What it will do, it will log the current provider, right? See here, Terraform uses the dependency log file .terraform.lock.hcl to track and select provider versions. The dependency log file is a file that belongs to the configuration as a whole rather than to each separate module in the configuration. For that reason, Terraform creates it and expects it to find in the current working directory. So that is why even if more than one .tf file is there, so for all the .tf files, only one .terraform.log.hcl file will be generated, right? And it will present in the root directory where .tf files are there. The log file is always named .terraform.log.hcl, and this name is intended to signify that it is a log file for various items that Terraform catches in the .terraform subdirectory of your working directory. Okay, so what is .terraform directory? So I just have shown you that within .terraform subdirectory, the provider is installed or the provider is getting downloaded, right? And to lock that provider, .terraform.lock.hcl file is generated. So let me show you one thing. If I change the version here 4.0 to 3, that means the provider version will be changed from tilde greater than 4.0 to tilde greater than 3.0, right? And we are not going to run terraform init. Directly we will run terraform plan. So let me check what will happen. Terraform plan. See, inconsistent dependency log file. The following dependency selections recorded in the log file are inconsistent with the current configuration. That means which Terraform provider version has been installed? It is still greater than 4.0, but what we have written here, it is still greater than 3.0, which is not present in our current configuration, right? So that is why it is saying that inconsistent dependency log file. And where all these things regarding the Terraform provider is mentioned, in .terraform.lock.hcl. In this file, it is locked actually. So until we run terraform init again, the terraform.lock.hcl file will not be changed, right? So let me run terraform init. So you see what it is saying? It is saying reusing previous version of HashiCorp/AWS from the dependency log file and failed to query available provider packages. So we need to use terraform init upgrade, right? Terraform init upgrade. Now see, Terraform initialization is completed now, and which Terraform version is getting used here? The AWS version 3.76.1. How we can check that? Under .terraform folder, you see dot 3.76.1. This has also been downloaded, right? And within this .terraform.log.hcl file, it is locked. The provider version is locked now. Okay, so now if I run terraform plan, it should work. See, what is the plan? 1 to add, 0 to change, and 0 to destroy, right? And which resource will be added? AWS S3 bucket dot terraform S3 bucket, right? So now what we will do? We will run terraform apply command to create the S3 bucket. So write terraform apply. Before running terraform apply, let's go to AWS console. This is our AWS console and the available bucket name is Suraj Bera, right? Now what I will do, terraform apply, enter a value, it will be yes. See, S3 bucket has been created now. Let me check. So let me refresh. See, this is our bucket which has been created just now using terraform file or using terraform configuration file. If you have observed here, one file has been generated. You see terraform.tfstate file. What is inside this file? You see what is the version, serial number, what will be the output, resource, everything is mentioned. So that means all the resources which is getting managed by Terraform is mentioned here. You see what is the bucket name? This is Suraj Bera 23 bucket domain name. What is the course rule? What is the hosted zone ID? Everything is mentioned here regarding the S3 bucket which we are going to create using this Terraform configuration file. So what is terraform.tfstate file? This file stores the current state of the resources created using Terraform configuration files in the current directory. This state is used by Terraform to map real-world resources to your configurations, keep track of your metadata, and to improve performance for large infrastructures. State snapshots are stored in JSON format. So I already have shown you the file, and in the file, the definition of the state which is getting managed by Terraform is defined in JSON format, right? And why terraform.tf file is used? It is used to store the current state which will be in sync with the real infrastructure in the backend or in the cloud. right? Now I will destroy the S3 bucket we just have created. So what is the command? Terraform destroy, and I will write auto approve to skip the prompt. Auto approve. Now see, our S3 bucket has been destroyed now. Let me check. So let me refresh this page. Now see, the S3 bucket is deleted now. If you have observed, another file named terraform.tfstate.backup has been generated. This is the file. So what is there inside this file? You see, again the definition of the resources which is getting managed by this terraform configuration file. See, this is the bucket ARN, this is the bucket name, domain name, everything is mentioned. Then what is there inside terraform.tfstate file? You see, there is nothing now. Only the version, terraform version, serial number, outputs, these are the things. And but in terraform.tfstate.backup file, the resources which were getting managed by Terraform are there. See, so what is terraform.tfstate.backup file? This file is backup file of terraform.tfstate file which is created in the current directory where terraform.tf file is present. A terraform.tfstate.backup file is generated before a new state is created. Now, in our case, there is no state because there is no resources getting managed by Terraform. We have deleted the S3 bucket, but at this moment, if we want to create the S3 bucket again, so it will take the input from Terraform state file, or the information about the S3 bucket is there in Terraform state file. But now Terraform state file is empty. So that is why, as a backup of the Terraform state file, terraform.tfstate.backup file is there. And within that backup file, the resource definition is mentioned. State snapshots are stored in JSON format like terraform.tfstate file. See here in line number 16, profile equals to default. But the thing is that how we have set this profile. So I already have mentioned, if we are using profile, then the AWS login credentials will be taken from credentials file. So where the credentials file is present. So see here, in this location, if you are using Windows, in this location, see user, then the username slash .aws. It will be present here, and this is the credentials file. So let me open it with Notepad++ or Notepad just once. See, you see, this is my access key ID and secret access key, right? And how we will set this value. So let me go to CMD. So AWS configure. So this is my access key ID and this is secret access key, right? And US East 1 is the default one. I already have written enter, and default output is in JSON format. So after putting AWS access key, secret access key ID, region name and output using AWS configure, all the values will be stored inside .credentials file under this path. Fine. But if we are not willing to use the profile parameter, then what we can do? We can directly provide the access key ID and secret key inside the Terraform configuration file. So let me do that. Copy, paste, copy, and I will write it here, right? So this will be uncommented and the profile will be commented now, right? So I will save this. Now what I will write? I will write Terraform plan. Okay, you see plan want to add. Now I will run Terraform apply and I will write auto approve. Our S3 bucket is now created. Let's check the same and refresh this page. See, this is our S3 bucket we just have created. That means it is actually working line number 17 and 18. We directly have provided access key ID and secret key inside the code, but it is not recommended to hard code the credentials. Every time we should use the profile attribute, otherwise we can use assume rule for this AWS provider. That's it for now today. We'll see you in the next video. If you really like this video, kindly like, share, comment and subscribe. Bye bye.